Okay, so our plan for today is to cover a bit new material related to fundamentals of object-oriented programming, which we already started a bit on our previous lectures. So, and let's start from presentation. So we will cover today only encapsulation. So main idea behind the encapsulation is to hide some parts of class and objects to restrict access to them. Abstraction it's mainly used for hiding some complexing part of our application, to provide something simple for user who will use our code. Inheritance, it's one of the way to organize our code. So, and polymorphism, it's something what allow to make our application more robust. So, but about these three we will try to speak later. It depends how it will go today. We will briefly cover object-oriented programming basics. So yeah, we already are familiar with two approaches, procedural programming and object-oriented programming. So I will just refresh your mind what was what. So on one of the previous lecture where we wanted to create array and do some manipulation with that, it was procedural approach. So we created some object and we pass it through the methods, procedures, and did some operation with that. So here we passed array in order to print it out. Later we pass it to some procedure in order to calculate sum of all elements, and so on. So it was procedural approach. And there is object-oriented, with which we are supposed to work most of the part. So, and that approach we tried on previous session. So when we needed to create some object and do manipulation with them. So we almost did the same as on lecture 14. We also have some array, but it was inside our object with which we did manipulation. So right now we haven't passed any data to procedure. We did directly manipulation with our object. Okay, so yeah, we already have covered what is object-oriented programming. It's when we manipulate with our object. So we say directly to them that we want to give salary to our employee. We want to hire a new employee to have a factory. Probably you remember these scenarios, what we have covered. So, and yeah, here's basic terminology for object-oriented programming. Everything what is on this presentation most probably will be on your test in next step for bootcamp. So later you will need to review it. So
this test will be at the end of this part?
it will be you okay, someone woke up, yeah. Some terminology will be required most probably on in order to pass tests for bootcamp too. So I'm not sure, but most probably. So okay, yeah, we already know that class is something from what we can instantiate some another object. Like we have class car, and we can create multiple instances of that class. So they will have common behavior and states definition of this. So, but they will be different. So we can create car from this class and define its own properties like name, color of this car, and so on. So it will, our object will belong to the class, and it will have same behavior and states as others, but we can specify how it should exactly behave. Okay. Yeah, you may think that instantiation of object it's like making copy of our class, but we just fill some empty gaps in our paper with some predefined, so where we can write down what the color is of our machine, what the maximum speed of this machine, if we speak about car class. Yeah, there is another thing what we already have covered, that class mainly it's data type. Class can store multiple attributes. So for the car, it will be the color of the car, the brand of the car, the maximum speed of the car. So yeah, and class create objects, but object it's one of the life of class. Yeah. Okay, and encapsulation. So encapsulation, it is one of the fundamental concepts of object-oriented programming. So there was another three. So today we will cover only encapsulation. So based on name, we can understand that it's something that close access to something. So we restrict access some states and variables, methods of our class, restricting access to it. So you may ask what for we may need this. So one of the reason could be, for example, if we have bank account. So we have there some owner of this bank account, we have balance of this bank account, we have some number of this account. So most probably we can easily provide information about our bank account number to everyone, but about balance of bank account, not really what we want. So it's good practice to prohibit, for example, get out more money from the bank account than we actually have on our balance. So if we have only 50 bucks and we are trying to take out a few hundreds, so we should prohibit to do this. So this actually do encapsulation. So prohibiting some unsupposed behavior is, you can think that it's encapsulation. So we don't want to give direct access to our balance. So we want to user at first check, is he allowed to do some manipulation? Isn't his account locked? Okay, and also in some way encapsulation simplify the maintenance of our code. So we will cover it some example. So yeah, there is some terminology, what it is, you will need to know it. So the main idea is that encapsulation hides the internal representation of a state from the outside of this class, and it controls access, who can really access it. So how it could be achieved? This could be achieved mainly with access modifiers like private, protected, public, default. We already have met them while writing our application. And with getters and setters, access modifiers. So let's roughly review what each modifier means. So if you don't know what exact modifier you should use, select private. So you shouldn't give more access to any variable method to more than it's supposed to be. So we should start from the most restrictive to the less restrictive. So private mean, so what we have marked with private, it is accessible only in scope of class. We can't access it in the same package. We already have used packages, but I will roughly cover them in a few minutes. We also may not set any modifier, just use default. So if we will skip it, it will mean that we still can access some variable inside of our class, and also we can access it from the class which is located in the same package. Protected modifier. So it's same as default, but also this value could be accessed from the subclass. So we haven't covered this, but it kind of will be taken into account when we cover inheritance parts. So in few words, car class, it could have some parent. Car is part of vehicles, so we can think about it like vehicle can move, and the car also can move, but it also has some additional behavior. It can open door, it can turn. Sorry. Yeah. So but car still has the same behavior as a vehicle. We will cover it later if we will have time and if we will go well. But you should know at least on test what for is protected. So it's allow for parent class. Sorry, it's allow for subclass access methods and states which is marked with protected in parent. And public, it means that this field, a method, a constructor, a class could be accessed from anywhere. Yeah, roughly it's all about theory. So now I would like you to cover packages to make it clear what for it's used. Oh yeah, let me create new channel and share this lecture and another stuff. I suppose that we will cover packages a bit earlier, but somehow we postpone it. So Okay, what we should know about packages. So packages in Java are used in order to group some classes by groups. For example, if we have classes which are related to mathematical operations, some mathematical stuff, we will put them into one package in order to simplify work with big bunch of classes. If, for example, our project is quite big and the amount of classes become hundreds, thousands, it will be quite hard to navigate over them. So it's a good idea to split them in logical groups. Also, it allowed us to avoid same name conflicts. So if we will have, for example, two users, so one user will be used, for example, for accountant system, another user will be used for medical system, but they both will be user, but they are used in different part of our application. So we couldn't have the same class with same name in one package. For these purposes, we need to move them in different. So it's another one reason. And as we have noticed from the previous slide, that we can also restrict access to our classes by packages. So if we will, access with default modifier will be available in scope of one package, but will not be available outside of this. So it's kind of packages also allow to us control the accessibility of classes inside them. Here I have provided some example of some default Java classes structure. So we have some package Java, and it's split on lang and util, and so there are many others. I just give example of few of them. We already are familiar with few of them. It's system class and string class. So system we used in order to print out into console. So, and also we are familiar with array list class. So yeah. Another thing what we need to know. When we create a new class in Java and we run it, then Java loads also few other packages. So it's load package with no name. It's kind of system package. There is nothing special, but it's loaded. And there is loaded Java lang package. So it's where string class is located, system class. So you have noticed that when we have used this, we did some work. So we created new string, then we don't load any special package here, so we don't import it. So it is loaded by default by Java, but from other way, arrays, we have used some function. Yeah, we have used here utility arrays to string, which is from package Java util, and we need to specify exactly that we want to import this. It's because by default is loaded only Java lang package, current package where our files, our class is located, and the package with no name. So everything else what we want to use in our class, we need to use import statement. Okay, what you need to keep in mind that package, it should be the top statement in our class. It couldn't be below import or below class. So, and package name should represent folder structure. So, okay, I will show it later. Our package couldn't contain spaces, and usually it is a reverse name of domain. It is used in order to distinguish projects and artifacts which is published by developers. So usually what we do, it's not used only on our machine. It's supposed to be used in different servers and so on. So, and we need to publish it somehow. And in order to distinguish our application, it's supposed that we will give name of our application in reverse name. So usually each company has its own domain, and we just use reverse name. So, for example, we are using com.accenture and so on. So, okay, let's take few examples with packages and then few examples with encapsulation. I hope it will become a bit more clear. So please don't type, don't do nothing. You will be able to do this later. So you may notice I have a project, RCS, and here I have some packages. So com.accenture and .lecture10, 12, and so on. So how it looks in folder structure. So let's see. So right now I am in that project, RCS, in my terminal, so I can overview what I have inside. So here is this source folder, and bin is just compiler code. Yeah, sure. Come on. Okay, should be good. And after that, I'm going into source folder, and we can check what we have here. Here we have 3 files and folder com. So let's see where from we get these 3 files. Oh yeah. So these files are located in our default package, so IDE don't know where we can put them, so they put them into the default package. And after that you can see that we have folder com, and inside of which we have folder Accenture. So again, here you can see that IDE decided to represent it one by one. So, but actually it's just tree structure. And if we will go deeper in Accenture, we can see that we have 6 packages, lecture 9, 16, 15, 13, 12, 10. Here they are. And we have some files also, and they're located in directly com.accenture package, and here they are. So here's the structure of our files in packages, our classes in packages. Can everyone see what I show on the screen? Okay, so it's quite straightforward. So I have created a new, okay, I will create a new. I click on a package where I want to create a new file, so I click new class, and here you may notice that IDE already suggests to me where I want to put this file. So I just give my package up. We will play a bit with packages and see how it works. So you may notice that there is already a first statement, the package, where is located current class. So it represents the file structure. And if I, for example, would like to access some file, some class from another package, I will need to do import. Let's see how it works. So I will create a new class in package com.extension, which is one level up. I will give just class from another package. We don't need to have nothing here. And I will try to create instance of class from another package in our test application. So, and you will see that IDEA told to us that class from another package cannot be resolved, and it suggests to us to import this one. So, and after imports, everything works fine. So, and now let's look how works the access modifiers. So, I have created this class as public, but if I will make it with default class modifier, so default means that just nothing, no modifier. And I will go here, I can notice that something is wrong. So, it says to me that it's not visible. So it's the main idea of these access modifiers. We can restrict from where we can access our files. We'll just move back. Okay, mainly it's all about packages. There was some task, but if you want you can play with them at home. So right now we will go directly to encapsulation. Okay, I have prepared some example. So by the way, I suppose that today we will work in pairs. Is there someone who wants to work alone, individually? If yes, please raise your hands. Okay, and then yeah, later I would like two others just to sit together. So, but at first I will show. Okay, so I prepared some code example, and I, after each step, did some commit in order to save time. So right now I will check out my code changes to some previous state. So using common git checkout and hash of each commit. it will bring my current state to specific commit. So not that one. Okay. So let's go back to our bank account. What we can do is this. Let's assume we have bank account which has owner, which is represented as a string, and some balance on our account. It's some money. You may notice that I have created this class inside another one, and it has default access modifiers, and all fields also has default access modifiers. What it means that I can access each field from inside of current class and from all classes which is located in same package as that one. So in this case it's Lecture16. Encapsulation example app also is located here, so I can access all fields. So for example, if I will say that it's private, it will not be accessible. It will have some errors, like owner is not visible. Okay, so and in our main method where our application starts, I have created new instance of bank account, and you can see that I have separately defined the owner of this bank account and some balance. And here I can do really bad stuff. I can say that I want to say balance will be -100, and most probably bank will not be happy with this one. So it's one of the problem, and this problem helps solve this encapsulation. So with the next step, I have added access modifiers to my bank account class. So I have set what encapsulation concept suggests, set modifiers, and restrict and provide access through getters and setter methods. So right now I have reduced the visibility level of my fields and just added getters and setters. So far so good, nothing special. And with next step we are going to restrict unwanted operations. So we don't want to directly set our balance to account. We need to add some control on it. We need to make sure before set some value that user has enough of money on it, and so on. So let's see how it will look. Here so far I just removed mainly the set method, so I prohibit to do some minus operation, and with next step we supposed to add some withdraw and deposit operation. We'll do some check that we are allowed to add some money. Okay, right now we see that we have constructor which receive initial owner name and initial balance. We can retrieve the current balance and we can retrieve the owner name by getter methods. And there was added few methods, deposit and withdraw. So right now we check that if user want to put some money on his account, this amount should be greater than 0. We should prohibit to put minus, so it's definitely should be checked. And only if amount which we supposed to put is bigger than 0, we add it to our account. In other way, we just say that inform that unsupported operation. And in case when we try to get some money from our account, we check what we check. Yeah, that if amount what we try to get is greater than our account balance, we say that failure to withdraw this. And also I have added to string method in order to easier understand what is the current state of my bank account, like who it is and what is the balance. So let's see what we have right now. We may create new account for John. We can say what is his name, how much money initially he had, and we can do deposit some money on his account. Let's see what it will be. Okay, so we successfully put some money and we print it out. So after deposit we have 110. Let's see what we can do else. So we can successfully take from his account 60 units of money. It will work fine because on his account much more money than 60. But if we will try to take one more time 60 from his account, so it will fail, because first time when we will take 60 from 110, it will be 50, and 50 is less than 60. And again, we also can't do deposit with negative value. So in such way we'll look this encapsulation. So we restrict to user do unwanted behavior by using access modifiers and some getter setter methods, and using separate method which controls state of our objects. Okay, I have prepared for you some tasks in order to feel more comfortable with this one and get some practice. So please sit in pairs as you want. Please join the first table. You may join. Remove heat from the work. Okay, I have sent in lecture 16 some link to document what could be useful for you. So here you will find my code, and we'll take a look what I did, how it looks. So also I want to introduce you with some basics of modeling. So in programming, it's widely used unified modeling language, which abbreviation is UML. Maybe some of you have heard about it. If not, then please get familiar. It will be often used. So it's used to generate, not to generate, but design the application, the software, the systems, and so on. So with this you can declare the class structure, the whole application structure, how classes interact between. So for now, I just want to that you get familiar with class structures. So let's see what we have. So here is a structure of bank account. So in top is mentioned the class name, what we have. So later we have the fields of our class. So the name of the fields and the type of these fields. So you may remember that here it was. So I have class bank account, and there was two fields, owner and balance, and owner had type string and balance has type int. And also what you may notice that there is some actually it is accessibility modifier. So minus means that it's private, and plus mean that it's publicly accessible. And below goes all members of our class. It's methods and constructor. So in such way, here you can see that here we have constructor, which has two arguments, owner and initial balance. And again, here you can see that the name of argument and its type. So yeah, and here is one example of some method. So we have method getOwner. It's public. You may see there is plus symbol, and it doesn't have any arguments, but it has return statement, return type, and it returns string. So let's take a look. So getOwner, what we can see here. So its return type is string, and it doesn't have any arguments, and it's public. So this diagram represents the structure of our class. Yeah, so spend a bit time, take a look how it works, and in next task I will send first exercise. Okay, you're looking for to a task, to a new one task, to a warrior task. Okay, so let's discuss what we need to do. You need to do in first task. So the structure is quite same as we have on previous lectures. So you will need to create class warrior up, which will have main method, where from our application will start work in package com_lecture16, and after that we will need to create a new class in separate file, warrior, but in same package as previous one, and you will need to implement this class in way what is defined in UML diagram. So it will have two fields, name and health, and some of methods. So getters are quite straightforward. The string also should be clear. If you will have any questions, please ask. And there is some criteria that warrior is alive if his health is greater than 0, and if his health is 0, we can't restore anymore his life, so he is dead. And yeah, warrior max health is 100. So yeah, if you have any questions, please ask.
I have a question about this Evernote. Why it's not opening on some
Sorry?
Evernote? Why it's not opening on some computers?
Why it's not opening?
This Evernote.
Is it opening?
No, here it is, but my work computer it's not. It's showing like blank. Reason or
Don't know.
it's not usual thing.
It could be some restriction on your network, for example.
Maybe of that one.
But it shouldn't be. Maybe if it's only some strict regulation in your company, but usually it should work fine. So try to refresh the page.
I was trying. It's not working. But okay.
So yeah, let's leave only one computer open on your desk. Try to move it on the middle in order that everyone can see. No, sorry. I think it would be nice if you would work with the previous session. You can write independently if you want. I don't remember it.